first, what goes second. My panda pal has to go to a panda party where he's bringing pineapples and prickly pears. But he doesn't know how to proceed. So, we gotta help him. So the sheet's gonna help me in a second, but first let's help my panda pal. I'm running out of P words here though. Pink pinatas are at the party, where the pandas are present. So, if you can, hopefully, don't say it, but hopefully you can see where the panda party is positioned. So hopefully you see the panda party. So if the panda is sitting right here, right now, shows up, and there's these three neighborhoods, what would be maybe the first direction or first piece of advice that you could tell, or Siri could tell Panda? Where could they go? What would be the first thing to tell them? Elm Street, yeah. Panda party is on Elm Street. So we would say, okay, it's on Elm Street. Awesome. If you still don't know where the panda party is, hold on tight. So I would say it's the Elm Street, right? I'm going to get more specific. Okay, so now he's on Elm Street. What would you tell him next? The sixth building, right? You wouldn't just be like, good luck, look for the balloons. Yeah, you'd say, okay, it's the sixth building. Okay, so he gets to the sixth building, and then?
Seventh floor.
Seventh floor, top floor, it depends how you want to, could be lobby, who knows, but the top floor, right? And then he gets there, and then you need to tell him the second room. Right, I mean, that in general is what we're doing, right? Okay, same concept. There's a thing called quantum numbers. When I'm done with this, you'll be like, wow, I like these a lot. Like, this is not nearly as complicated as I thought. I mean, when you talk about pandas, how hard can it be? But it's a specific address of an electron. There's these things a long time ago called envelopes, and on these envelopes we would put ink from pens, and it would have a thing called an address, and you could do this other thing called like a letter or mail, and you would put it in a mailbox, and you'd send it to people. And you could go from specific to most general. So you'd say a state, and then you'd say the city in that state, right? And then you say the street, and then the number on that street, and then it gets to that house. Not only does it get to the house, you can write who it's to in that house, right? It gets more specific, but you can't be like Bob, Wisconsin. Like, that's not enough, or just Bob. Like, oh, I hope it gets to Bob. Let's see. I wonder if they open that up, or they just throw it away and just wrote Bob. You think you'd want to know what's in it. Anyway, so let's talk about this. Underneath, I have 4 lines. I'm just going to give you a moment. Can you just please copy this all down so then we can just talk about it? Believe me, it looks more confusing than it actually is. There are 4 pieces of information that we can give for the location of our electron, just like my panda pal. I needed a thesaurus. I could have had a lot more P words, I'm sure. Pterodactyl, yes, but that doesn't use my alliteration very well. The first time I ever saw a pterodactyl written, I'm like, what is this word? Like, that's pterodactyl. I'm like, no, it's not. You don't know what I'm talking about. You've never seen pterodactyl written. It'll blow your mind. And then when you're done, please place that one electron. But you want to write these down because there's some vital information. I don't. I just rip it all up. Okay, so as you're finishing this up, quantum number is a number. So the hardest part, honestly, is the second value. So what we're doing is, okay, we are narrowing this down from the most general to most specific. You can't say right now, oh, the electron, it's in the upper right. It's 6 away from the upper right line. Like that doesn't work. It just doesn't. We need to be more specific than that. So the first line, like the panda pal had a street. We said which street he was on. Same idea. You have energy level 1, energy level 2, energy level 3, energy level 4. So we would say that this is on the 4th energy level. What I'd like you to do is make this electron really, really, really big, because we're going to do 3 other ones, and I don't want that to be confusing with the numbers we're doing on this. Like, make it nice and exaggerated. Okay, so now I wish I could do this. Imagine all this is gone. Okay, I have these. So now what did we do with our panda? We said which building it was, right? Well, we can say which sub-level it's on. Is it the S? Is it the P? Is it the D? Is it the F? Here's the issue. It's called quantum numbers, not quantum letters. So I can't say F. So this is the one thing you have to remember is that it doesn't start at 1, 2, 3, 4. It goes 0, 1, 2, 3. I didn't make this up. That's how it works. So F is a 3. And that's why you have that written. You need to make sure you have those letters down. So S is 0. You can even just remember that S is 0. And then you just count over to the right. All right, now I'm here. Right, I'm on here. The panda went in the building. Now you have to tell him he was on the top floor. You have to tell him which orbital. That's what this means, orbital. Well, you can't say like second from the middle, or you have to use a number. So what I like, they have really, makes a lot of sense. It says orientation or location on the sublevel. Please write these down. What we do is, just so you can see them as examples, we take the middle of a sublevel, and on that middle orbital it gets a 0. We go to the right, sorry left-handed people, we go to the right, it's +1, we go to the left, it's a -1. Okay? Let's compare and contrast on that one. If we did a D, to the right it's +1, to the left it's -1. Oh, I got to go over further? Fine, it's +2. It's -2. S's are awesome and weird at the same time, because there's only one line. It's a 0. So then, where is this one located? Well, if that's the middle, where is it? It's at -2, right? And this would go to 3 and -3. So my orbital orientation is -2. The last one, it's pretty straightforward. You can't have 2 electrons, called the Pauli exclusion principle. Don't have to worry about that. But no 2 electrons can have the same 4 quantum numbers, like all 4 of them. So if you have another partner here, what would the other electron have to look like? It had to be a down one, right? So this up one is just what I wrote. If it's pointing up, you get a +½ If it's pointing down, you get a -½ So the quantum number of this electron is 4, 3, -2, +1/2. That's how you'd say it. What I'd like you to do quickly, please don't make these as big. I want you to place some other ones. And just put an arrow, you have a bunch of open space, you guys, and do these. Please, they have commas in the middle or in between, but you don't have to do the line itself. So I'll give you a hint on this first one, right? This one here, you start with a 3, correct? And this one? And then you put a comma, and then you should have 3 more numbers. So work on your own. If you want to compare with someone else, I'll give you about a minute here to do these 3. They don't usually take all that long. And then let's see how we do as I hand out to you. Can you guys have a bunch of open space? You can just write it right to the sides. I just want to get the first one done in case we're getting stuck and maybe this wasn't your first one. But if I look at this, first number is 3, right? Then the next one would be a 2 because of the D. And then the location would be +1 and then -1/2. Right? You technically don't, it's good to do so, but you wouldn't get marked off. I mean, you got to have the negative for sure. Yeah. Yeah. That'd be okay. The question was, do I have to have the plus on there? I've seen both. It's not the worst thing to put it on there, though. This one, there's a 3 again. Why is it a 1? Because it's a P. It's in the middle, so that's why it's a 0. And it's pointing up again, so now that's +1/2. So the last one. It gets confusing the first couple times you do it, but S's are usually the easiest. If anybody ran into this, you're like, wait, what? Like, okay. It's on the second level, so it'd been a 2. The S itself gets a 0, right? Where are you on the S? 0. And every S has 0, 0. Every S is 0, 0. So this would be 2, 0, 0 plus 1/2. Every S is a double O in the middle of it all. Okay? So, that's how you do quantum numbers. So I have a worksheet that I gave you. On the top, you guys, is a pre-made beginning of a cheat pyramid. You need to draw in the lines, okay? Then, if you're just looking at this with me, please. The first 4, I believe, or 3. First 3, I've created the structure of an orbital diagram just to make sure you're understanding how it should be structured out there. Put the electrons. Please don't think that you have to fill every line. Fill every line that you need to with the electrons. Like, there could be extras. On the right side, you do the electron configuration, and then there are just a couple of problems. There's not that much. It's more about giving you the space. And then on the bottom of the back, I don't know how many I gave you, maybe 7, something like that, quantum numbers. Okay? If you're not sure about which one it's pointing to, please ask us, but for the most part, I think it's pretty straightforward. It's not that much work. This is a pretty small worksheet, and it's a good way to start practicing this, okay? We do expect that I know it's a 4-day weekend, I know that it's time to decompress and everything else, but by the end of the day on Monday, this is due because we're going to be working on stuff, and we're not adding, we're adding different ways of shortcutting this actually. How can we make this shorter? How can we write electrons and orbital diagrams even shorter? I've actually shown you the most complicated things to do now. We're actually going to make it easier moving forward. Okay? So, if you want, you can maximize the time now. That clock is fast. So I would like you guys to start working on it. But energy and waves and your lab are due today. That is a priority. Make sure that is taken care of.